Yeah, so I started. Hello, everyone. Welcome to today's session of our Analytic Philosophy Circle and a special event of UAnalyticon. A bit of information about Analytic Philosophy Circle and UAnalyticon. Analytic Philosophy Circle was formed in 2006 at Philosophy Department of Ural State University in Yekaterinburg by Dmitry Ankin, Alexander Sabantsev, and me, Lev Lamberov. At that time, Alexander and me were last year undergraduate students, and Dmitry Ankin was my supervisor. Since then, we meet almost every week to discuss various works, both from classics of analytic philosophy like Gottlob Frege and Bertrand Russell, to many contemporary cutting-edge papers and books. Later, some more participants joined our circle, most notably Ilya Gushin, Olga Kozareva, and Victoria Sukhareva. That's great that all of them participate in our discussion today. And another participant of our discussion is Anna Moiseyeva from Institute of Philosophy and Law of Siberian branch of Russian Academy of Sciences. So when it comes to UAnalyticon, it is an annual conference on analytic philosophy. We organize it since 2011. The organizing committee consists of Dmitry Ankin, who is the head of the organizing committee, Ilya Gushin, Alexey Kislov, Olga Kozareva, Victoria Sukhareva, and me again, Lev Lamberov. We pick up various topics for each year's conference, and the next UAnalyticon will take place in May 2022, and it will be related to abstract objects. Our today's discussion is a kind of precursor of it. A bit later, you can find more information about UAnalyticon 2022 at our website. Also, you can subscribe to our YouTube channel to get some up-to-date information about our discussions, special events, conferences, and other activities. And again, thanks for watching this stream now. Okay, the topic of our discussion today is abstract objects of some special kind. Today we will discuss a book by Øystein Linnebo, professor of philosophy at the University of Oslo. The book is entitled Thin Objects, an Abstractionist Account. Øystein kindly agreed to join our discussion today, so hello Øystein, and thanks for joining us. It is a great honor and pleasure to have a chance to learn about your ideas from you and discuss them with you. Øystein's book, Thin Objects, was published in 2018 by the Oxford University Press. It discusses some Freudian topics in metaphysics and philosophy of mathematics, like abstraction principles, the nature of abstract objects, natural numbers, and also develops a modal approach to set theory. Some parts of Øystein's book draw on his previously published papers, but the book presents more detailed and expanded discussion, and in some aspect supersedes these papers. Okay, let me stop at this point because it definitely would be much better if Øystein present his ideas himself. So, Øystein, please.
So thanks a lot, Lev. That's great to be here, and I think it's very nice that you have this forum for analytic philosophy with such a lot of activity and these nice workshops that I've participated in one of before. The plan then is to give you an overview of what I do in thin objects before proceeding to a discussion. So the idea then is that certain objects do not demand very much of reality for their existence. They somehow come very cheaply. They're lightweight, metaphysically, different ways to think about it. And this is an idea that has been around for a while. One version of the idea comes up in connection with structuralism, where you find Hilbert writing in the famous debate between himself and Frege. that if a theory describing a structure is consistent, then the structure and its objects exist. Those are my words, not Hilbert's, but that's the gist of it, that consistency somehow is sufficient for the structure described by that theory to exist and the objects of that structure to exist. And then Hilbert, in his own words, says that this, for me, is the criterion of truth and existence. Okay, so here you have very much an idea of thin or lightweight objects. Consistency of a theory suffices for the existence of the objects in question. So the bar to existence is put very, very low here. There's another completely different route to thin objects, which I call an abstractionist route. And this one is nicely illustrated by Frege on directions. So you have the famous Fregean criterion of identity for directions, that the direction of one line is identical with the direction of another line, just in case the two lines are parallel. And according to Frege, the two sides then of this criterion of identity, they somehow demand the same of reality. They are maybe recarvings of one and the same fact. So as a result, then, once you have the right-hand side, you get the resources to refer to the directions on the left-hand side, right? So you have the parallelism of two lines, and that suffices to say that, well, the line of one is identical with the direction of one is identical with the direction of the other. And what I do in the book that Liev mentioned is to really pursue two aims. And one is to articulate and defend a version of the abstractionist route to thin objects, the route I talked about. So I think it's important to be aware that there are many routes to this idea. There's also the structuralist route, which is also interesting and promising. But what I do in the book is to defend the abstractionist route without in any way criticizing other routes. So there's a positive aim here, not a negative claim to the effect that this is the only way to make sense of thin objects. The other idea to which Liev also alluded briefly is a kind of dynamic abstraction. So you have the so-called bad company problem, namely that when you look at abstraction, there are many problematic cases mixed in with the good cases. And in the literature, it's been very difficult to separate the good from the bad. And the book then pursues a new response to that problem based on the idea of doing abstraction dynamically. So kind of doing it again and again and letting the domain increase as for every round of abstraction, as it were. So those are the two main aims, the idea of thin objects and the dynamic abstraction. And let's start then with the first of those aims. The big challenge here is to explain this idea of thinness. So I mentioned the direction criterion of identity, where the idea is that the demands on the world made by the left-hand side, the direction of one line is identical with the direction of another line. These demands do not go substantially beyond the right-hand side. Okay, so although the left-hand side talks about directions, the right-hand side talks just about lines. Nonetheless, the directions invoked on the left-hand side are for free, in a sense, relative to the right-hand side, because they don't go substantially beyond. Now, that idea of not going substantially beyond can be cashed out in two different ways. Certainly, the most immediately obvious way to cash it out is that they don't go substantially beyond these demands, since they don't go beyond at all. So you have what I like to think of as a symmetrical model of abstraction, where the two sides are completely on a par concerning what they demand of reality. And that is a view you find in Frege, in the Neo-Phrygians. It's developed in a lot of detail by Augustin Rao. But I'm unhappy with it for a couple of reasons that we can discuss if you wish. So one of these reasons has to do with ontological commitments. So I would like to take seriously the impression that we have that on the left-hand side, there's a new ontological commitment not present on the right-hand side, namely a commitment to directions. And if so, then ontological commitment is a worldly matter, and the two sides are not on a par with respect to ontological commitments. So you can't have a symmetrical model. Another reason to favor a more asymmetric conception has to do with metaphysical explanation. So I like to see the right-hand side here of the direction principle as providing a metaphysical explanation of the left-hand side. And that too would mean that the two sides are not completely on a par. So what I'm after is a conception where I can say that, look, the two sides are not completely on a par with respect to demands on reality, but the left-hand side doesn't go substantially beyond what's demanded by the right-hand side. So it's a kind of insubstantial or light way of going beyond what's demanded by the right-hand side. So what I need then, what I want to get that asymmetric conception going is a notion of sufficiency, where the right-hand side suffices for the left-hand side. So I'm going to write that sufficiency as double arrow, and we want that relation. And just to get a very rough sense of what that relation of sufficiency might be, I think it's useful to think of all the attention you have these days to the notion of metaphysical grounding. So many of you have probably come across that from Kit Fine and others. And then the idea that the right-hand side grounds the left-hand side. Somehow the parallelism of the two lines provides a complete metaphysical explanation of the identity of the associated directions. That comes at least close to this notion of sufficiency that I'm after. What the book does, though, is to articulate a kind of job description for the notion of sufficiency. So it had better be ontologically expansive, that the commitments of the left-hand side can exceed those of the right-hand side, including ontological commitments. And yet, as you move from the right-hand side to the left-hand side, so as you move from here to here, you preserve epistemic status and you preserve explanatory status. So let me explain what I mean by that, looking at the case of epistemic status. So if phi suffices for psi, and you know phi, then that should potentially give you knowledge of psi. Okay, so you can potentially preserve that good epistemic status of knowledge. So the relations of sufficiency, in other words, provide a way of expanding knowledge. And likewise with a metaphysical explanation. So this is just laying down a job description for something I want, and then there's a question of whether we can get what we want. That's not a given. So the book is an attempt then to show that we can define, characterize, make sense of that notion of sufficiency. And the way I do that is by seeking inspiration from Frege, who has very sophisticated and interesting thinking about these matters. And more specifically, in the Foundations of Arithmetic, section 62, Frege raises a really, really good question that has come to dominate much of the later philosophy of mathematics. So how then, Frege asks, are the numbers to be given to us if we can't have any ideas or intuitions of them? So it's a very good question. We don't directly perceive or intuit numbers. So how then are they given to us? I guess we could also add that we don't in any way experimentally detect them unlike subatomic particles, say. So there's a real question of how we get any kind of semantic access to numbers. They're abstract, they're not directly given to us. How then do we manage to refer to them or have access to them? So I see that this, as you can see, as anticipating the problem later associated with Paul Benazerev. And Frege does not only, in a very nice way, articulate that problem, he also proposes an answer. And the answer is given in this passage, which follows immediately the passage on the preceding slide. Since it's only in the context of a sentence that words have any meaning, our problem becomes this: to explain the sense of a sentence in which a number word occurs. So you have the problem of how do these number words refer? How do they come to have their meanings? And the proposed answer is that, look, meaning is something that words have only in the context of a sentence. So look at the complete sentence and try to explain how that gets its meaning. And via that, the hope is, we will get an account of how these singular terms that occur in the sentence, including the number words, how they get their meaning or reference. And criteria of identity play a very important role here. This is again following directly from the preceding. If we are to use the symbol A to signify an object, we must have a criterion for deciding in all cases whether B is the same as A, even if it's not always in our power to apply this criterion. Okay, so when you look at the sentences whose meaning needs to be explained in order to explain how number words come to refer, identities are particularly important. They're really, really important. So we saw that a little bit already in the talk about directions, right? Where you have that criterion of identity for directions in terms of lines. And that seemed to play a role in how we use direction terms to refer. So Frege has really a triangle of related notions here: objecthood, reference, and criteria of identity. Very general, abstract, logical, metaphysical notions, and they're related according to Frege. So firstly, this connection: to be an object is to be a possible referent of a singular term, is a Fregean idea. Next, it suffices for a singular term to refer that the term has been associated with a specification of the would-be referent, which figures in an appropriate criterion of identity. Right? So how do you refer to a direction? Well, you specify the direction by means of a line. So you say this direction, demonstrating by means of a line the direction that you have in mind. Okay, so you have a specification of a would-be referent, and that specification figures in an appropriate criterion of identity. That if you have a different specification of a direction, that direction, say demonstrating with a different line, then that picks out an identical direction just in case the two lines are parallel. Okay, so this gives you that link from identity criteria to reference. And you see that this link makes reference very easy to come by. All that's needed is a specification of the would-be referent and this criterion of identity. So this gives you easy reference, and since you refer to objects, that gives you easy or lightweight objects. So this is looking promising. The last link is that abstraction may result in a larger domain. You may come to refer to more objects than what you had at the beginning of this process. And using that, you could provide even more criteria of identity for yet further objects. So you could travel around this triangle in the direction of the arrows. Now that's all pretty abstract. So let me now become a little bit more concrete and tell you about a toy model of that conception of reference and the constitutional reference that I've talked about from Frege. And what I propose to look at here is a toy model of reference to physical bodies And we're going to simplify a lot. So the agents doing this reference, they will be robots, very simple robots embedded in and interacting with a physical environment. We'll focus on the senses of sight and touch. And the question will be, under what conditions can we ascribe to a robot reference to a physical body? And by physical body, I mean things like rocks, pens, a ball. So it'll become clearer as we go along. Yeah. So what does it take to refer to a body then, a physical body for this robot that we're looking at? Well, the robot has to receive perceptual information from some part of the body. That's a specification that we talked about. So say the robot is seeing a piece of rock sticking up out of the lawn, and it can say that body, that rock. But it's not enough to have this perceptual interaction with specifications of the body or parts of the body. The robot also needs a mechanism for determining when two such pieces of information are associated with the same body. Right? So maybe 2 meters away, the robot sees more rock sticking up out of the lawn. And the robot then needs a way of determining under what conditions are these two pieces of rocky material part of one and the same physical body. Right? Is the robot referring now to two distinct physical bodies, or to one and the same? So a mechanism for determining that is needed, and this is what I call a unity relation. And here you need to pay attention to what these bodies are meant to be here. So they're meant to be three-dimensional solid objects, to have relatively natural and well-distinguished spatial boundaries. So an undetached half of an apple, say, is not a physical body. Only the whole apple is a physical body. Bodies are meant to be units of independent motion. So if you pull one apart, then the rest of the body is at least disposed to come along. Bodies move along continuous paths, and they have relatively natural and well-distinguished temporal boundaries. So all of that you could somehow program into the robot, and then in that way give it a unity relation for determining of two parts of physical matter, U and V, whether they stand in the relation of picking out or belonging to one and the same physical body. So then you get this criterion of identity that the body associated with some rocky material, in this case, is identical with the body associated with some other rocky material, just in case these two parts of rocky material stand in the unity relation that we have talked about. And I want to highlight something quite striking about this. The account we have given, I have outlined, or what it takes for the robot to refer to a physical body, that talks about parts of bodies, so these chunks of physical stuff, and relations between these parts. It does not talk about the physical bodies themselves. So in that sense, there is a kind of reductionist aspect to the account, that we're accounting for reference to physical bodies in a way that doesn't itself talk about physical bodies. It only talks about their parts, these chunks of material stuff, and relations among those parts. So hold that thought. That'll be important as we go along. Yeah. So there are different kinds of criteria of identity. Some of them have this logical form, that you provide a criterion of identity for certain objects in terms of a relation among those very objects. That's not very explanatory when it comes to explaining reference, since you're referring to the objects in question on the right-hand side. So what I will use as my model for explaining these matters are so-called two-level criteria of identity, like the direction criterion of identity. And these are called two-level because you provide a criterion of identity for directions. That's the aim. And the criterion is now stated not in terms of directions, but in terms of certain other objects, namely these objects that serve as specifications of directions. So in general, a two-level criterion of identity has this logical form, that you have some entity, alpha and beta, some kind of entity. Could be lines, could be other things, we'll see soon. And then you have a function term applying to these specifications, alpha and beta, and saying that alpha and beta specify one and the same object, just in case alpha and beta are equivalent in a certain sense. Or you may work with partial equivalence relations. Let me not go into details here in this quick summary. What's important here is that with the two-level criteria of identity, there is that kind of reductionist character that we talked about in the case of bodies. Right? You say something about what it takes for these Fs to be identical. That's said in a way that doesn't itself talk about Fs. It just talks about specifications of Fs and relations among those. So again, there is that reductionist character to two-level criteria. And that makes two-level criteria really promising when it comes to explaining how reference to Fs is constituted. Since there's now explanatory progress, what enters into the explanation is are just the specifications and relations among those. So material that can be presupposed, that doesn't itself presuppose what you're trying to explain, namely reference to Fs. There are many, many examples of these two-level criteria. So here are some. I talked about physical bodies presented or specified by means of partials of matter and the unity relation we talked about. We've talked about directions specified by means of lines with the unity relation of parallelism. Linguistic types provide another good example, or indeed any kind of types. It could be book types or what have you, specified by means of tokens. Excuse me, and then a relation of two tokens being co-typical, as I call it here. So being so as to be specifications of one and the same type. Cardinal numbers, one natural way to go here is that cardinal numbers are specified by means of pluralities of things under the unity relation of equinumerosity, so being such that the two pluralities can be put in 1-1 correspondence. Right? So my left-hand fingers are equinumerous with my right-hand fingers, since I'm putting them in 1-to-1 correspondence. And then sets, lastly, specified by means of pluralities again, and with a more demanding unity relation of co-extensionality. You may worry about paradox here, and you're right to do so. We'll see in a little while that there's a response on my account to all these paradoxes. All right, so that was a bit of material about criteria of identity and using these criteria of identity to give content to identity statements involving a new type of objects that you weren't previously talking about. That's giving content to identity statements, but you need more than just identity statements. You also need predications made of these new objects. So here, there are certain property inheritance principles, which are very nicely illustrated by the case of directions again. So we can say that two directions are orthogonal, right? They're at right angles to each other, just in case they are specified by two orthogonal lines. So here we start with the notion of orthogonality of lines. That's well defined. And we observe that for the purposes of assessing orthogonality, one line is just as good as any of its parallels. Right? So I could replace L1 with L1 prime for any L1 prime parallel to L1. Okay. And that observation allows us then to say that the relation of orthogonality that you have defined on lines, that can be inherited by the directions that are specified by means of lines. So we define in this way a relation of orthogonality among directions. And orthogonality among directions is really inherited from orthogonality among the lines that serve to specify these directions. Right? So it's important to get this example, since everything concerning these property inheritance principles is contained in that one illustrating example. We can generalize, of course. I'm going to put this up, but don't worry so much about the details. All you need to know is really contained in the key example of orthogonality. What we do here is to look at formulas phi that don't distinguish between equivalent specifications. Right? So if you have a bunch of equivalent specifications, if phi holds of one list of those specifications, it'll hold of the list of equivalent specifications. Then you can use that formula phi to define a predicate phi star that's defined on these objects that are introduced by abstraction by means of this inheritance principle. And we now get to a slide where I kind of lay out the statement of the view as a whole in this book. So referenced by abstraction. So we look at a two-level criterion of identity that provides identity conditions for Fs in terms that presuppose only some antecedently accepted ontology, but not Fs. And we're assuming that an agent has an appropriate grasp of the unity relation, uses a criterion and these inheritance principles to govern her talk about Fs. And our agent stands in appropriate relations to specifications in the field of the equivalence relation or partial equivalence relation, and uses all this to make claims about the resulting abstract objects. Then the claim is the agent is in fact referring to these objects, so the abstraction has succeeded. If two specifications are equivalent, the agent can truly assert that the associated abstract objects are identical, and likewise for the property inheritance principles. That's a summary. The red things I have indicated here are claims that need to be further spelled out and further defended, and that the book then does spell out and defend. But since this is just a summary, let me see how I'm doing for time. Not too badly. Since this is just a summary, then I'll tell you now how this notion of sufficiency that I said I wanted, where we gave that job description, how that can be defined. And it should be relatively clear what we can do now. So you can say that phi suffices for psi if phi is a ground for asserting psi in a language extension of the kind that we have described. So look at the case of directions. Then the parallelism statement between L1 and L2 suffices for the identity statement among the corresponding directions. Likewise for orthogonality, and likewise for the negated statements. Okay, so we now have defined our notion of sufficiency. And one question it's good to ask here is how a nominalist would respond. What would a nominalist say to all of this? So the nominalist would accept that, yeah, sure, lines exist. We may take the lines to be physical lines. But why should these suffice to specify directions? Why should I, the nominalist, accept that? And the answer I'm giving is that, look, there's really no alternative or more direct or secure way of specifying directions than what I've given you. And if you refuse to accept that most direct way of specifying or picking out a direction, namely as the direction of this or that line, you could make an analogous objection in the case of physical bodies. Right? So I say, look, our robot has referred to a physical body, and you may be a skeptic about physical bodies and say, why should I accept that? I see there's a partial matter here and a unity relation, but why should I accept the physical body? But here too, the response is that, look, I've referred to the physical body in the most direct and secure way that is available for such things. So that won't end the debate in any way, but it reveals that there's no special threat to abstract objects here. So the kind of objection that the nominalist is voicing here could equally well be leveled against the case of physical bodies. Right? So this has to do with how do we specify in certain very fundamental ways reference. It's not reference to abstract objects specifically, it's reference quite in general. And expanding the domain, here's a little bit more about what I would say to the nominalist. So I'm going to tell you about how the domain is expanded in 3 steps, where you introduce reference to objects to which you weren't previously referring. So first, we start speaking as if there are directions. Let's just use the language in accordance with these rules. So when the left-hand side obtains, we're going to use that as a ground for asserting the right-hand side. We'll just start speaking that language. Why is that okay? I claim it is okay. Why is it okay? Well, the assertability conditions here are in good logical order, and they're stated in unproblematic terms. Everything is entirely predicative. So the grounds for asserting various claims about the new objects are all characterized in terms of antecedently accepted or old objects. So it's very difficult for a nominalist or skeptic here to deny that we're at least allowed to start speaking as if there are these new objects, because that way of speaking is logically in perfect order, and provably so. Well, step 2 is to ask then, how should the extended language be interpreted? And I'm claiming that an interpretation of the extended language that takes its apparent reference to directions at face value would be preferable if it's available. So there are a couple of different reasons we could talk about in the discussion to think that taking apparent reference to the new kinds of objects, taking that at face value would be preferable if possible. And the third step is to argue that that interpretation that takes that apparent reference at face value is indeed available. For you could use a meta language in which this interpretation is specified. As that kind of meta language, you avail yourself of the very same form of reference to directions. Okay, so I explain how you say refer to directions, and you do all that fancy stuff about lines and parallelism. For me to pick out the directions that I claim you are referring to, I too will avail myself of lines and parallelism, because that's the best we can do. So there is a kind of internalism about reference here, that there's no way of specifying the reference to directions or physical bodies or whatever the case may be in wholly different terms, because this is a basic way of specifying reference. There's no more direct way of doing it. This account of sufficiency satisfies the desiderata, or so I claim. it's certainly ontologically expansive. New objects are introduced into our discourse. And you preserve, I claim, epistemic status and explanatory status, or at least potentially so. And why is that? Well, when you expand the language in that way, you may or may not be completely aware of what you do, but none of what you do is, in principle, unavailable to you. An explanation can be articulated, and you can understand what you do and see that as knowledgeable. So the book promises an account of thin objects and has a contrast between thick and thin. So let me tell you a little bit more about how that plays out at the end. So how thick or thin an object is will depend on the demands that its existence makes on the world or on reality. So the sufficiency statement governing the object or discourse about the object says that one side is for free relative to the other side. And then you just examine how much does the phi here demand. So in the case of physical bodies, they're relatively thick, they're relatively demanding, since they make quite specific demands on a particular region of space and time. Namely, that there's got to be matter in that region of space and time, and that matter has to belong to one coherent whole that satisfies its unity relation. That's a fairly heavy demand, making physical bodies relatively thick. Directions, by contrast, are pretty thin, not maximally thin, since directions are specified by means of lines. So there's got to be a space to begin with in which you can have these lines that specify directions. So directions are far towards the end of thin, but not maximally. So sets or cardinal numbers are very interesting, since in some cases the phi that suffices for something else, that may be absolutely undemanding. So take the empty plurality, no things. No things are equinumerous with no things. Okay? That equinumerosity truth, which demands nothing whatsoever of reality, that suffices for the cardinal number 0 to exist. Now you've got a larger plurality, namely empty plurality plus 0. That is a one-membered plurality, and its equinumerosity suffices for the existence of 1, and so you go. So you get then, out of nothing, as it were, all the cardinal numbers. So the cardinal numbers here on this account are maximally thin. They demand nothing whatsoever of reality. So I've spoken now for about 40 minutes, and I'll use the last 5, max 10 minutes to say a little bit about the bad company problem. So the problem of separating good and bad cases of abstraction from one another, and how I propose to answer or solve that problem in a new way by allowing the domain to expand in the kind of way we have talked about. And the problem is nicely illustrated by means of Frege's basic law 5, or you could have a plural version of it. So take sets to be specified by means of pluralities of things. So the set of these is identical with the set of those, just in case these are the very same things as those. Okay, it's a version of basic law 5 that gives rise to Russell's paradox. So what went wrong? And my diagnosis here is that this basic law 5, here we attempt to provide a criterion of identity for sets in a way that quantifies over, and for that reason presupposes the very sets in question. Since this is done in the ordinary setting where you have a fixed universal domain once and for all, a domain that you quantify over here with a for all z, And in that domain, you have the very sets that we are trying to account for on the left-hand side. So you're presupposing the very objects for which you're trying to provide a criterion of identity and to which you're trying to account for reference. So a kind of impredicativity or circularity. And my solution then is to allow the domain to expand and to insist that all the abstraction steps here be predicative, in the sense that the introduction of new objects can only ever presuppose old objects. So objects that you have already accounted for and that you have already specified how you can refer to. Okay, so you've got the old objects, we're assuming those to be in good order, and then you can introduce reference to new objects, provided you do so in a way that draws just on the old objects. There mustn't be any kind of presupposing the new objects to be introduced. That is dangerously circular and gives rise to the kind of problem that you have in the case of basic law 5 in the ordinary static setting. So let me then illustrate how you can have this idea in practice of predicative abstraction, of introducing the new in terms that presuppose only the old. Okay, so we'd like to accept certain sufficiency statements. Right, so alpha 1 equivalent to alpha 2, that suffices for identity, etc. And then the claim is that you presuppose only a domain of old objects if each specification, each of the alphas, is one or more objects from the old domain. Okay? The objects you're relying on in specifying the new objects are just old objects, right? That's observing the presupposition requirement. And then the relations among those old objects that you are considering, the equivalence relation and the phi, they must be intrinsic to the old domain, in that all their quantifiers are restricted to the plurality of old objects. And when you look at the case of abstracting sets from pluralities of their elements, that is exactly what you have. So you've got some old objects, XX and YY, and then when these are one and the same lot of objects, you say that they specify the same sets. That's entirely a statement about the old ontology. Old objects said to be the very same objects as some other old objects. And then membership is membership talk is introduced from plural one of talk. So when X is one of some things XX, we're going to say that X is one of the sets specified by XX. And this claim on the left again is only about the old. Okay, so here you really are doing what we promised to do, namely presuppose only the old. And it's super interesting then to compare the conceptual analog. So let's, instead of specifying set-like things by means of pluralities, let's try to specify them by means of concepts or properties. So when two concepts are coextensive, say that their sets are identical. When a concept applies to an object, say that that object is a member of the specified set. And I claim that this is problematic, this is dangerous. And to see that, you could look at the concept of being a member of itself, say, and look at the associated set. And then you look at the sufficiency relations here. So the right-hand sufficiency is the one we have here, right? That's what we're laying down. And then why does little f have the property f? Well, that's because it satisfies the definition of the property f, which is this. So here you see that the ground that you provide for making various statements, asserting various literal statements, so atomic or negated atomic statements about the new objects, they do not succeed in avoiding talk about the new objects or talking solely about the old ontology. So we have a literal about the new object such that neither it nor its negation is grounded in a truth that is solely about the old ontology. In huge contrast to what we had on the previous slide with pluralities. So the upshot here is that when you're interested in set abstraction and you want to do that dynamically, then when you do it by means of pluralities, then you really observe the requirement we lay down that you must only ever presuppose the old ontology and relations on the old ontology when characterizing new objects and their properties. And dynamic abstraction is then saying that whenever or provided you observe that requirement of presupposing only the old ontology and relations on the old ontology, go ahead and abstract and do that again and again and again. And you can iterate these abstraction steps many, many times. And as Liev alluded to, I developed that using modal resources. So you can say things like, necessarily given any things, possibly the racer set. Meaning that you, however many times you have extended the language, look at any things you've got, you can extend the language again so as to introduce a reference to the set of those things we just talked about. And that then gives rise to a very strong modal set theory, strong enough to interpret ordinary ZFC set theory. There's a question about what kind of absolute generality you get here. You can get a form of absolute generality even in this setting by combining modal resources with the ordinary quantifiers. So you can say that however many times I extend the interpretation of my language for all the objects I have reference to, then it is a case that so-and-so. So that is a device that gives you absolute generality. And likewise with possibly there is. And you may worry then that, look, didn't I just give you a way of extending reference using some objects to refer to yet more objects? And can we use that trick to break out of even the absolute generality I claim is achieved here? So is there a kind of revenge problem in short? And the answer is no. You see that when you look at the details of the argument I gave for being able to extend the interpretation. So here it was essential that the domain is given in a way that's extensionally definite, say by means of a plurality. And that allowed us to specify the new objects using these plural means. And that is the way in which the domain can be extended. So what follows here is only that the domain of absolutely everything is not extensionally definite in that way. Here's the triangle again. I'll be brief this time. So you see how the account here really travels around and around the triangle. You start with some objects. Using those objects, you provide identity criteria for new objects that you would like to be able to refer to. There is an account, Frege-inspired account of how reference is relatively easy to achieve. So using these identity criteria, provided they're predicative and presuppose only the old ontology, that reference, attempted reference, does indeed succeed, and you get the resulting object. And sometimes especially as we saw in the case of sets. Going around like this gives you more objects. So you could formulate yet more identity criteria, refer to yet more sets, get yet more objects, and you travel around. So that's the dynamic aspect. So let me stop there so we have plenty of time to discuss.
Okay, thank you, Øystein, for the presentation and summary of your book. I personally really liked your book very much. It is very motivating and understandable. Understandable, especially compared to some of Michael Dummett's works, who is mentioned as a kind of inspirational for some of your ideas. And your book is motivating for me because naturally I'm rather into a nominalist position. The conception of abstract objects raises some serious doubts in me, and your book just make them much easier to admit. I mean, much easier to admit the existence of at least some abstract objects for which we can use abstraction principles to find out the identity criteria and an easy reference. Okay, it's time for some questions. And I think one of the first question one would like to ask you concerns the status of abstraction. Sometimes we think of abstraction as a kind of human activity, a part of reasoning, and a part of an ability to reason. So is abstraction a human activity? If yes, then how is it possible that our creative activity results in something that already exists? And if not, then what it is?
Yeah, that's a great question, which raises very big and hard questions. Yeah. So abstraction is a human activity. I think that is right. So when we start talking about directions, say, that is something that we do. So we formulate a criterion of identity for directions. We start using lines or oriented lines to try to pick out directions. So in that sense, at least, abstraction is something we do. And likewise with sets that we have, maybe at the outset, plural resources, we can talk about many objects simultaneously. And then using that ability to talk about many objects simultaneously, we talk about single objects, sets, that somehow encapsulate all of those many in one. So in some sense, abstraction is a human activity and something we do. But I guess there are two things to be said here to not go too far with that observation. So one is that although this is a human activity, that does not mean that the entities, the objects that we're explaining a reference to, are constructed by us humans. Okay, so what is a human activity is to introduce into our language the resources to talk about these objects. That is not to say that the objects were created by us. What's created by us is a linguistic way of introducing into our language reference to these objects. But the objects were there. The objects were not created. They have always existed insofar as ascribing to them time makes sense at all. So the objects are either eternal or atemporal. And likewise, in many cases, the object will be necessary existence. So once you have introduced, say, reference in your language to the empty set, it's correct to say that the empty set would have existed even had there been no human beings. Right? So super important to distinguish then between what we do and what we do not do. So what we do is expand our language who else could do that? That's got to be something we're involved in. But then by expanding the interpretation of our language, we just got the resources to now refer to objects that are not our creations. So objects that Martians could refer to equally well as us, or that were there to be referred to by anyone, whether or not that possibility of referring to them was ever realized by anyone. Okay, so that's one thing I would say to remind us that we shouldn't go too far with the constructivist implications of what I said. And another thing that I would like to say to remind us not to go too far is that even when I talk about the human side of things, so extending the interpretation of our language, I look at highly idealized extensions. Right? So extensions where you iterate abstraction steps maybe infinitely many times, and that is not something that we finite humans could in fact do. So here we're idealizing. So I hope that makes sense. So yes, the core observation of the questioner is correct, but in two respects, you mustn't go too far.
Okay, thank you. So, Øystein, how are thin objects related to theoretical constructs like ideal gas, black and white bodies, or infinitely deep water as it is treated in the analysis of water waves?
Oh, nice. Yeah, that's a very good question. Yeah. So infinitely deep water is invoked then in order to do, I guess, hyperdynamics or study of waves in a good way. So it's an idealization that makes a lot of sense, that we come close to actual hydrological phenomena come close to, and it's easier to study the phenomena under those idealizations. And a relation here between that and my account of abstraction is that my account of abstraction too idealizes a lot. So there too, there are very, very strong idealizations. So of course, when you look at very basic uses of what I do, so take this, introducing just about sets of physical objects into our discourse. That is something we can actually do. But pretty soon, once you start iterating these abstraction steps many, many times, you're idealizing massively and beyond than what we humans in fact do. So I think the relation that comes to my mind between these examples you mentioned from a theoretical context and my study here has to do with the reliance on idealizations. I hope that helps.
Yeah, thanks. And so a bit more about thin objects and the relations to some other kinds of objects. Mm-hmm. How are thin objects related to fictional objects? Like, can we think of, say, Sherlock Holmes as a kind of thin object which we abstract away from some real-world detectives?
Mm-hmm. Yeah, that's a good question, and you could certainly try to use my framework for talking about thin objects to analyze and get a handle on fictional objects. It's not something I've done myself, but you see the kind of framework here for extending our discourse. So you could try to fit fictional objects into that framework. So if you could specify how fictional objects are, or if you could explain how fictional objects are specified for us. So they're specified by means of some alpha, alpha 1, alpha 2, and also provide inheritance principles for how you ascribe properties to fictional objects, and then you could do it. Then you could use this model. So why not? So let's think about it then. So how would fictional objects be presented? So Sherlock Holmes, you mentioned, probably presented by means of just a story, in this case, the Conan Doyle novels, using the name Sherlock Holmes as if to refer to an object. And then you could have many different references to Sherlock Holmes coming up in different Conan Doyle books. And they would possibly be, these specifications of a fictional object would possibly be equivalent, right? And then I guess you could even, if writers get a bit more creative here, have Sherlock Holmes crop up in someone else's novel, right? So other people too have written novels where Sherlock Holmes comes up. And maybe you recognize that as a specification of the same fictional character, so an equivalent specification by using the same name or somehow some intention to have that be an equivalent specification. And then property inheritance, yeah, so various properties are ascribed to Conan Doyle and ascribed to Sherlock Holmes by Conan Doyle. And yeah, then too, I think you would have the conditions satisfied for a kind of property inheritance. So the framework gives you everything you need to try to get a handle on fictional objects too. One worry here would be that in the case of fictional objects, the raw material that you find on the left-hand side of the sufficiency arrows, that would be less clearly, precisely defined than in the mathematical cases that we're looking at. Right, so suppose you write a novel in which you talk about a detective who's remarkably Sherlock Holmes-like, but you don't use that name, say. Is that an equivalent specification or not? Maybe there's no fact of the matter. So things will be messier, less clear-cut in the case of fictional objects, but that isn't to say that you shouldn't try. So I think it's a nice suggestion, and it would be nice to try to adopt this framework to analyze fictional objects. Definitely.
Okay, then let's get a little bit back to the question about the status of abstraction. So you say that an empty set is eternal, and we just expand our language. So is Sherlock Holmes also is Sherlock Holmes also an internal object like an empty set, or
oh,
what?
that's great. That's great. That feels wrong, doesn't it?
Yeah. So how do you distinguish between an abstract object like numbers, a theoretical or idealized object like a center of gravity or an ideal gas or a black body, and a fictional object, fictional entity like Sherlock Holmes or Hamlet? Do you think that all of them are thin objects in the same way?
I think there will be very important differences, and I think this slide will help us out a little bit to see what the difference is. So we have the sufficiency statements, right, where the thin objects or objects reference to which we're constituting on the right-hand side, and then you look at what's required of the world by the left-hand side for the right-hand side to obtain. And then I claimed that when you look at the number 0, for instance, then the empty plurality and its equinumerosity with itself suffices. And that's, of course, nothing. Right? Nothing is required. That holds in any possible world at any time or irrespective of time. So this gives 0 then a very strong independence of time and circumstance. Right? So this gives 0 kind of eternal or atemporal status and a necessary status. It's not contingent. Okay? So far, so good. Then look at something like the fictional objects. So there you would have specifications of the fictional objects would involve authorial attempts to pick out or refer to an object. And that's a contingent matter that you have those specifications. Right? That does make a demand of reality. So for Sherlock Holmes to exist, there have got to be attempts to pick out such a character as Sherlock Holmes. Because that's how Sherlock Holmes is specified. So the ways in which the fictional object is specified are non-trivial. The ways in which the object is specified impose substantive demands on reality. And also demands that have to do with time, right? So for instance, to refer to one and the same fictional object, presumably there's got to be some causal connection between the different specifications of that fictional object. So if people use the name Sherlock Holmes in some remote galaxy, then to also talk about a detective, then that's presumably not the same fictional character, since it's there's no causal connection. So the equivalences that you or unity relations that you need will also bring with them quite specific demands having to do with time. So you could then probably say that Sherlock Holmes was introduced in whenever it was that the Conan Doyle first wrote his Sherlock Holmes book, and that is when Sherlock Holmes was, I guess in that case you would say created, yeah. And the attempt then is to have that drop out of the story, not be something that you just impose from the outside. So it's meant to drop out of the story by looking at what does it take to refer to or specify the relevant object. And then it takes much more to specify a fictional character than it takes to specify the number 0 or some other pure abstract object. Yeah.
Yeah, okay. So Sherlock Holmes is a kind of radical case, I think. And what about an ideal guess?
An ideal
Is it
guess,
internal?
yeah. An ideal guess. I'm not sure my model fits the case of ideal guesses. Then I would have to hear more. Maybe you have something in mind, but I guess I'm not seeing how my model fits ideal guesses, other than that both my model is engaged in very heavy idealizations, and talk and reasoning about ideal gases is also involved in very major idealizations. But beyond that, I don't think there's too much in common. But did you see ideal gases fitting into this framework that I'm talking about in some way?
Well, at least I think that ideal guess, the concept of ideal guess can be formed in some similar way to concept of numbers you discuss in your book. That is, we observe some various guesses and then we abstract away some of the properties to make our theories much simpler, I mean, in mathematical sense.
Yeah, okay, good. So a kind of abstraction going on even in the case of ideal gases, that you abstract away irrelevant details. Yeah. Yeah, that's very interesting. But an ideal gas, would you get it to fit into this kind of framework? So how would the ideal gas be specified? Do you have specifications with a unity relation on it? That's what I'm not seeing.
Yeah, that's very tricky. Yeah.
Yeah. So, but interesting. So in both cases, there is abstraction. That's right. So I'm doing Frege style abstraction where you have an equivalence relation, and then you latch on to what is shared by those two equivalent entities. Right. So take the case of cardinal numbers, maybe. So you have a plurality and another plurality. What's shared by those pluralities when and only when they are equinumerous? And then you get cardinality. So that's a form of abstraction. And then you have a kind of abstraction when you look at ideal gases. You abstract away from all the irrelevant features. Yeah. So it ought to be possible to have an even higher level account of abstraction into which you could fit both of these phenomena. So my Frege-inspired abstraction and ideal gas abstraction. Yeah, so that sort of the idea, the core idea of abstraction is to abstract away irrelevant details, focusing just on essential features, maybe features that are shared under a certain equivalence. May well be possible. I have not. I do not have such an account offhand, though.
Okay.
I guess one thing I could say that's in a little bit vein is that I talked about structuralism and the Frege style abstraction. And in structuralism too, there is a kind of abstraction going on. Maybe it's not so much in the version that Hilbert is talking about here, but when you look at mathematical structuralism, the way it's been discussed in the philosophy of mathematics literature over the past decades, then often we talk about a system of objects and relations, and then you compare that system with an isomorphic system of objects and relations. And then you say, the structure is what these two isomorphic systems have in common. Right? So that's looking at what's shared by across a kind of equivalence. And in that structuralism case, the kind of equivalence is isomorphism. Right? So it's not an equivalence of individual items like directions or pluralities of objects or something like that. It's now an equivalence relating whole systems of objects and relations. And in that case, I think you can, you do get a challenge, kind of like the one you mentioned, of asking, here are two kinds of abstraction. I want you to know what they have in common, or if there's some sort of umbrella under which they both fit. And here I think it's clearer, since even in the case of structuralism, you have an equivalence obtaining between what you may see as specifications of whole abstract structures, and the equivalence in that case is just isomorphism. So if you could somehow get an equivalence into your account of ideal gases, that would help.
Yeah.
Yeah.
And another question. So if we do not create thin objects and we just expand our language to speak about what already exists, then how can we accommodate all of the abstractions that we, in principle, can find out, especially in the case if we are concerned with the question of how many objects exist in the world?
Yeah.
And so how can we think about this maximal domain, which consists of all objects?
Mm-hmm.
Is it possible to
yeah.
speak about it in just, say, one concept or something like that?
Yeah, good. So how can we think about that maximal domain of all objects? That's great. Yeah, so we have a way of expanding the domain that we can talk about, which I've articulated in the form of these predicative abstraction steps. So that allows you to always expand beyond a domain when that domain is what I call extensionally definite. So when the domain is given as a plurality, just a plurality of things, so it's definite which things are in that domain. Yeah, then you could use that plural character of the domain to say that, hey, I want to talk about sets from among those many things, expand beyond that in the way that I defended, and that gives you a larger domain. And then the question, if I get it correctly, is what can we say about the kind of absolute domain of all the objects that can be introduced in that way, right?
Yeah.
Yeah, and that's where I try to use modal operators and quantifiers together to get that kind of stronger generality. So the quantifier itself ranges over one of these extensionally definite domains that lends itself to expansion. But the modal operator then says that for any way of extending the interpretation of the language or expanding the interpretation of the language, it'll be such that everything you then have is thus and so. So that gives you then a way of generalizing over absolutely everything, not just everything that you have introduced reference to now, but everything to which you may ever come to introduce reference. That's a claim now. And then there was a worry I talked about here that, look, why can't you go beyond even that kind of reference, the absolute reference? And the answer is that, look, that absolute domain is not extensionally definite. That cannot be thought of as just a large plurality of here are all the things in that domain. That domain is now intentionally specified as here are some things, here are some ways of expanding the interpretation, and look at all the ways of expanding the interpretation, and perhaps yet further ways that you may think of later, and everything that could be referred to in that kind of way. But that doesn't, is the claim, that doesn't specify the domain in an extensionally definite way. So that is a totally different kind of domain. And this is really interesting and really important stuff, that a domain can be specified extensionally, and most of the domains we deal with in ordinary discourse can be so specified. Right? So I speak about all the citizens of Russia, or all the philosophers of the world, or whatever, and these domains can all be specified as a plurality. But here I make the pretty controversial claim that there is no plurality of absolutely everything. Right? There's no plurality of all objects whatsoever, or also no plurality of all sets whatsoever. And this is a big commitment, and it is a source of controversy. This is in no way a small thing, because we do say in ordinary English talk about all the sets. So, right, that's a plural phrase, and you may think that there's got to be some plurality of all the sets to which that plural phrase refers, and I have to deny that. So that's a point where I need to say that we're being misled by natural language.
Okay, so this absolutely maximal domain is not extensionally definite because abstraction never stops, right?
That's right. Yeah.
Okay.
Yeah, abstraction never stops, and whenever you have a domain that is extensionally specified, then I argue it's possible to expand that domain by abstraction. Right? And why is that? Well, this is where you have the core idea that it's fine to abstract, provided the introduction of new objects only ever presupposes the old objects. Right? And then we look at the way of using a plurality to specify reference to their set. Then here on the right-hand side, you have various claims about the new objects and new sets that you want to introduce into your discourse. And always here, the truth conditions for various claims concerning the new sets are stated in terms that involve only the old objects. So that's why I claim that this is so hard to resist. Since you've got the old objects, let's all assume that we do to grant that. And then here's a way that's provably in good logical order of talking about yet more objects, where all the claims about these yet more objects have truth conditions that are stated just in terms of the old objects that we all accepted. Right? So that means, I argue, that in this case we can expand. So whenever precisely as you say, Liv, that whenever the domain is takes the form of a plurality, then an abstraction step is available that takes you beyond.
Okay. And also, again, about some kind of empty possible worlds. Many thinkers claim that empty possible worlds are not possible. They do not exist. And I think your conception of abstraction and thin objects gives another argument against the claim that there are empty possible worlds, since an empty possible world should contain an empty set, a singleton of an empty set, and so forth. So it's not empty, right?
Yeah, that's nice. I had not thought about that implication, but you're right. Yeah. So let's consider an attempt to have an empty possible world. In that empty possible world, you'll have the empty plurality. So no things, and no things are equinumerous with no things. And then on this account, you get the existence of zero, and then you bootstrap and get all the natural numbers. So even that world with that's empty of contingent or physical objects, you will have an infinity of natural numbers. Yeah, that's right. And I guess it's worth observing here that this gives you a reason to believe that old and familiar metaphysical claim that pure sets exist necessarily and cardinal numbers exist necessarily. So often that is just asserted and it seems very intuitive, it seems plausible, it's very widely accepted, but here you actually get the nitty-gritty of why you should believe that by showing what it is that these objects depend on and tracing those dependencies all the way down into something that's patently undemanding. And that would have the effect that you observe. Very nice.
Okay. Another question. Does the symmetric view of abstraction allow to formulate a model set theory? Obviously, the symmetric view of abstraction constitutes a different type of accessibility relation which is symmetric. So it would require some other model logic, right?
Mm-hmm. Yeah, there are two ways to take that question. So symmetric model of abstraction, yeah. So you could mean that as, or you could take that to mean a symmetrical relation between the two sides of the abstraction, that there's really no difference in what the two sides demand of reality. So this is what Frege seems to have in mind when he talks about recarving of facts. So the two sides of the abstraction principle here are different ways to carve up one and the same fact. And certainly what Reo has in mind in his work. And on that symmetrical conception of abstraction, it's not very natural, I think, to have a modal set theory or modal account of abstraction at all, since there's nothing that really is built up successively. Since here, it really is as if here's reality with some lines, and then another way to see the parallelism of those two lines is as the identity of the associated two directions. There's no difference. While on my asymmetric account, you start with this, based on that, you get to the left-hand side. And likewise in the case of pluralities on the right and their sets on the left. So then there's a move from something to something else. And that something and that something else would naturally be modeled by possible worlds where the domain increases. So I don't think the advocates of a symmetric conception of abstraction would be interested in a modal explication of their ideas at all. But there was another way to aspect of the question too. Talking about a symmetric accessibility relation among the worlds. So let's take a view on, let's see where this comes. Yeah, so I talked about introducing modality to, yeah, here. Oh, so you iterate abstraction steps, okay? And then we need some way to model the iteration of abstraction steps. And then one pretty natural option is to use modal resources to study the iterated abstraction steps. And could you then have a modal logic where the accessibility relation is symmetrical? So where you have the Browerian axiom that if phi, then necessarily possible phi. Yes, that is possible. And in fact, when you look at some other ways of developing this, like the way of James Studd in this article, Abstraction Reconceived, or in a book that came out the year after mine, for that matter. And he has he uses a modal logic that's as strong as S5, So with the Browerian axiom and symmetrical accessibility, but his modal logic needs to be free as the result. There's a little bit of freedom here to choose different ways to do it. Let me end my response by just saying a little bit about why I prefer the accessibility relation not to be symmetric. And the abstraction steps I see as ways of introducing referential resources into our language. And you add more and more referential resources to the language. You never, as it were, lose referential resources. So if the accessibility relation were symmetric, then you could start at a place where you can refer plurally to many things simultaneously, but not yet refer to sets. So then you expand by means of predicative abstraction, you get to refer to sets. And if the accessibility relation were symmetrical, then you could also lose that ability to refer to sets and somehow see back to where you came from, where you could only refer plurally. But what is it to lose the ability to refer that you have gained? So once you have that ability, you retain it and don't lose it. Yeah. So I find it natural to go my way, but it's not absolutely obligatory, as Studd's excellent work illustrates. Yeah.
And I have rather somewhat bigger question for you. And this question is related to the concept of infinity and its relationships to potentialist hierarchy. So typically the numerable set is presented as something prefixed, like there is an axiom of infinity which states that there exists an infinite set, and this infinite set is not finite, obviously. It is not extensionally defined. It is defined by means of a procedure on how to generate this set. But this procedure cannot be finished. Otherwise, the resulting set would be finite. When we speak of this finite set, we speak about it as object. We speak about it as about an object. But is there such an object? How can we come to the idea of the numerable set? Well, probably by generalizing the potential infinity. We know that for each number there exists the successor. We know that any finite set or sequence of numbers can be extended. We may repeat this procedure for indefinitely long time. And I think that the most important term here is indefinitely. Then how can we speak of this denumerable set as of something definite? This denumerable set is indefinitely extendable. Therefore, it cannot be defined extensionally as a kind of finished object. How can we speak about an unfinished object of this sort? And the main question concerns your principle of modal reflection. It says that truths about the potential hierarchy of sets are reflected in truths about individual possible worlds. So if there exists the mentioned denumerable set in the potential hierarchy, it should exist in some particular possible world. But I wonder, how is it possible, since sets in your modal set theory inherit the extensional properties from pluralities, which are stable and extensionally inextendable? You claim that the principle of modal reflection is a natural principle. Okay, but I currently don't understand how it fits into your conception. Could you comment a bit on it?
Yeah. No, this is an excellent question. It's very good. Yeah. So yes, there is a potentialist aspect to my approach, right? So it's dynamic abstraction where the domain is successively being built up. I'm speaking loosely here. What's really being built up is our ability to refer, but the result is then that we get ever larger domains, and that sits very, very naturally with the idea of potential infinity. So take this one, and maybe the sets here are just finite sets. So necessarily where you are in that process of expanding the domain, take any finite sets, you could introduce, any finite number of things, you could introduce reference to their set. So that's a finite set, and now you have a larger but still finite number of things in your domain. So this principle is, you can see that as a kind of saying that at least you have a potential infinity of hereditarily finite sets. And you could have an analogous principle for the natural numbers, that necessarily for any number, possibly there is the successor of that number. Right? So then you have a potential infinity of natural numbers, or a potential infinity of hereditarily finite sets. And then, as the questioner observes, I want to take the leap at some point from saying that you have that potential infinity to there is a corresponding actual infinity. And the actual infinity then is to say that when you look at all the sets that are being generated in this way, at least when the XX are finite, you could collect all of them together in a vast plurality of the hereditarily finite sets. Or in the case of natural number, you could get a vast plurality of all the natural numbers. And that would mean that you have an extensionally definite way of talking about the collection of hereditarily finite sets or of natural numbers. And of course, if you accept that there is that extensionally definite collection of natural numbers, then you could use that as a springboard for generating yet more numbers. So you could have introduce omega then, or you could have a set of all hereditarily finite sets, and then you're off to into the transfinite. But what the questioner wants to know is what justifies the move to saying that where you have a potential infinity, characterized by this one, you could collect together all the objects so generated into this one big extensionally definite plurality. What justifies that? And that is a truly excellent question. And the answer is that you could use a lot, or let me say two things in response. So you could use a lot of this framework that I'm developing here and say that I disagree with Linnebo on these actual infinities. I want to be a thoroughgoing potentialist when it comes to infinity. Any legitimate notion of infinity is that of potential infinity. That's one way of taking my framework. The second remark is that I am attracted, obviously, to saying that some of these potential infinities can be turned into corresponding actual infinities. And what justifies that? Well, here the evidence is less clear-cut, it's less absolutely compelling. It's starting to be more abductive in character. So this is starting to be something that's justified more by, it seems to make sense, it seems fairly natural. This is where Cantor was so influential in showing us how lovely a mathematics this gives rise to if you just take that step of saying that the potential infinity of natural numbers corresponds to, or can be taken to correspond to, an analogous actual infinity. So that seems to make sense. We make the leap, we explore it, we see how it works. It all hangs together beautifully. It's very explanatory. So you then get all these abductive benefits of making that leap into the actual infinite, into the transfinite. So that's how I would justify it. It's not that the leap, as I'm calling it, is absolutely forced upon us or absolutely required, but it is natural. We have a relatively good understanding of it. Once you make it, you see that there are major theoretical benefits from doing that. So it's kind of a mixed response here. That yes, let us make the leap, but be aware of what we do. It is a major leap, and you've now moved from more elementary mathematics into transfinite mathematics, and the evidence that supports you at this point is thinner. So you've got to be more careful and a bit more measured about what you claim by way of evidence for what you do.
Okay, let's see. The least inaccessible cardinal. I guess it is inaccessible because it is not possible to reach it by means of other axioms of set theory, that is, procedures which are defined by these axioms. So even lots and lots of finite sets which are extensionally definite. So these finite sets together cannot constitute even the least inaccessible cardinal. And I still cannot see how to reach it with your abstractionist approach.
Ah, good, yeah. Well, that's good. So, and with the approach the way it stands, it can't be reached, and provably so. So we know that because you can give a model, you could use, so using set theory in our meta language now to reason about things, I can use the least inaccessible kappa to show that V kappa gives a model for my abstractionist set theory. Right. So since if you have a least inaccessible, you prove a model for my theory, then that theory itself can prove the existence of the least inaccessible. So what to do? You've got to go beyond that theory if you want the least inaccessible, and add yet further principles of set generation. So
we need to use some kind of oracle or what?
Yeah, that's a good one. So how good a motivation can we provide for the existence of the least inaccessible from within my framework here? Yeah, that's a very good question. So I guess you could try a step kind of like the step that took us from the potential hierarchy of hereditarily finite sets into a plurality, into an actual infinity of all the hereditarily finite sets. Yeah, so you have this generative way of characterizing a potential hierarchy of hereditarily finite sets, and you say that I want to assume now, perhaps tentatively, just to give it a try, but I want to assume that there is a plurality corresponding to everything generated in that way. And now we have, in the full account that I offer, there are stronger generative principles, since you have both replacement and power set. So you then have a potential hierarchy that goes all the way up to the least inaccessible, right? Since the least inaccessible provides a model for that potential hierarchy. So you could say, let me try the same move again of saying that I want to try to close off that potential hierarchy and look at the least plurality that's closed under all the generative principles adopted thus far. Okay, and that plurality, which we're tentatively accepting now, that would be the plurality of all the sets in our V kappa. Right, and that plurality can be used to define the corresponding set. So then you have V kappa as a set, and then you're off to go yet higher. So I think that's how I would try to do it. but then with even more epistemic modesty that we're trying this tentatively, and it's a big leap, and we've got to be careful. But it has worked out wonderfully and in a very successful way.
Okay, so let's get back to the ground from the heights of
Yeah.
set theory.
Yeah.
What do you think about the utility of symmetric relations of sufficiency for defining the concept of meaning and criteria of the sameness of meanings of two utterances? Is it so? Can we use these relations in some non-trivial cases?
Mm-hmm. Yeah, very good. So let's see what's a good place to. This I think this is what I wanted. So symmetric relations of sameness of meaning, and then use that to define meanings was the idea. Yeah, I think that's very promising and is the best way to try to approach reified meanings, really. So a meaning on that account would be specified by means of some meaningful expression. So the specifications of meanings would be strings of words or expressions of some language, formal or informal. And then you have a relation of synonymy on those meaningful expressions. And you try to characterize synonymy as best you can. And then abstract your meanings from the meaningful expressions under that equivalence relation of synonymy. The challenge will, of course, be to make sense of that notion of synonymy. So in practice, that has been rather difficult to have a well-defined notion of synonymy. But I think there's one lesson here at least, namely that you shouldn't be particularly worried about reified meanings. What's problematic or controversial or is a substantive assumption here isn't really the invocation of reified meanings. It's the reliance on this well-defined notion of synonymy. That's the crux of the matter. Right? So that's what the debate should be. Do we have a sufficiently well-defined notion of synonymy? And I guess in special cases, in highly regimented cases, we do have an adequately well-understood notion of synonymy. Right? So you could do that relative to a dictionary that stipulates what the relations of synonymy is, or you could do it relative to a dictionary, or relative to a thesaurus. So a dictionary just within a language, or a dictionary across languages that specify cross linguistic synonymy relations. But when you look at the Quinean worries about synonymy, then a dictionary wouldn't be enough. He would ask, in virtue of what is that dictionary giving a correct account? And then you look at synonymy out in the wild among users of language, and that is very, very difficult to pin down. But there's something very interesting about it. So I've looked at abstraction here, Frege-style abstraction, where the material you abstract on is all clear-cut, mathematically sharply defined. But can we have versions of this account where the material you abstract on isn't so clear-cut or sharply defined? Like the case of synonymy. That would be great to investigate and see what you can do. And what can you do when the relation here is kind of fuzzy. It's by and large an equivalence relation, but there are problems on the edges. What to do? It's a very good project.
Okay. And I have also somewhat bigger remark. I really liked chapter 10 of your book. That is the chapter on natural numbers, where you argue that ordinal conception of numbers is more fundamental to our everyday usage of numbers than cardinal conception. And I agree with you. While reading this chapter, I was thinking about some additional argumentation besides what you present in the chapter. I don't think I found something brand new. I think I saw something similar probably in Paul Benacerraf's papers, but I may be wrong about it. So probably you can recognize the argument and remind me where it was presented. And I will not dive into details, but rather give a sketch of it. The claim is that cardinal numbers and also numbers as equivalence classes, as in Frege and Russell, are in no order in case there are no natural numbers in meta language. I admit that it is possible to order cardinals by comparing their cardinalities. However, it requires that on some particular stage of ordering, we will know cardinalities of all cardinals. Since we are into natural numbers now, we can limit ourselves to finite cardinals. But even in this case, we should know cardinalities of each set from the class of all finite cardinals, which itself is infinite, right? So such ordering will require a lot of resources. One may wonder when we should know cardinalities of all finite cardinals to order them. And my answer is that this is the only way for us to properly decide which cardinal should be used as 0, which cardinal should be used as 1, which cardinal should be used as 2, and so forth. And we need to compare them pairwise to decide. Then one may object that we already know that empty set should be used as 0, a singleton should be used as 1, a pair should be used as 2, and so forth. And I answer that such reasoning requires natural numbers in meta language. One may generate cardinals in a kind of natural order like Frege does in his Grundlagen, but still it presupposes that we already know which cardinal we should generate first, which cardinal we should generate after it, and so forth. Which I think all shows that cardinal conception of numbers is not our basic conception for everyday usage of numbers. Moreover, ordinal conception is more fundamental than cardinal conception, since the latter presupposes the former. And I understand that structuralists will definitely object that we don't need to find only one true cardinal to play a role of 0, another one true cardinal to play a role of 1, and so on. And currently, I don't have an answer to such structuralist objection. And I need to think about it a bit more, but at least I think it works. It kind of works against logicists and neo-logicists like Frege, Russell, Wright, and Hale. So what do you think about it?
There's a lot there that I agree with. So it's a long remark, and I think I agree with just about all of it. So there was a mention of Benacerraf there, also arguing for the primacy of ordinals. That must be from his famous What the Natural Numbers Could Not Be paper. And so there but that's in a more structuralist vein, what he develops there. But it's kind of an ordinal conception, but in a structural manner, and where you're not abstracting on numerals in the way I do. So what I do in chapter 10 is to take numerals to really play a key role in our way of specifying natural numbers. So the most direct, useful way of specifying a number is by means of a numeral written in some notation that we're familiar with. So for us, typically the decimal notation. And a very nice feature of proceeding on the basis of numerals there is that the numerals come in a canonical order. We all know that 1001 follows immediately after 1000. The numerals, that is. And that's completely immediate from the notation that the numerals stand in that order. And that order is then inherited by a property inheritance principle by the natural numbers themselves. So you don't have to contend with this otherwise big problem of ordering the cardinal numbers that you would have. So I agree with all of that, and I guess I would add that alongside the abstractionist ordinal conception of number and the abstractionist cardinal conception of number, there's also a structuralist conception of number. And I think that too is mathematically useful, mathematically legitimate, and so there are many ways of thinking about the natural number structure. So there I'm a bit of a pluralist. I like the ordinal account, especially when it comes to being an account of our more basic kind of elementary school level arithmetical competences. Once you're up at university level, we probably go structuralist concerning the natural numbers.
Okay, thanks. So I personally don't have any more questions, and as I can see, there are no questions at all in YouTube chat, and since no one raises their hands, I guess there are no questions.
And we've had a long and good discussion. Lots of good questions here.
So yeah, if you have something to say, kind of concluding remarks.
Not other than that I'm very grateful for all the work you've done thinking about the book and my ideas. Some excellent questions here, a lot of fun things, including then possible avenues for extending the account into, say, reified meanings or into fictional characters or maybe even ideal gases. So room for further work. The other thing I wanted to mention, since it occurred to me just now, is that when it came to creating the book cover, I didn't do that myself. Oxford University Press and their designers helped me with that, but they asked me for ideas. And I pointed them to some posters and graphic art by Rodchenko, and said that's something you kind of like that would be really cool, since I had seen an exhibition of Russian modernism at the Tate Modern while living in London, and this is what they came up with. So there is actually a Russia connection in the book cover.
Okay, great. Okay, so thank you, Øystein, very much for joining our discussion and for your summary and your answers to the questions. It was really great experience. Yeah, thank you so much.
Okay. Thanks a lot, Ben.
Yeah.
Okay.